Alright, some practice problems. It says determine which functions are exponential. The first one is y equals negative 1/2 x plus 5. That is not exponential, that's linear, because it is not a base raised to a power. So that is not exponential. The next one, g of x equals 12 times 9 to the x. That one is. You got 9 raised to a power variable. C, f of x equals log base 7 of x. That is not exponential. It can be rewritten as an exponential, but you don't see an exponent in there, so not exponential. And the last one, y equals 4 times e to the 2x. Yes, you have base e raised to 2x, so there's a variable in that exponent. So that one is exponential. Alright, some equations here. Solve the following and round to 4 decimal places. The first one is 8 equals 4 to the x. So to get that x out, let's change it to logarithmic form. So we'll have x equals log base 4 of 8. That's an exact answer. We can rewrite that using the change of base form as log 8 over log 4, and then we'll put that into the calculator to get an approximation. Okay, so that approximation will be to 4 decimal places, 0.6021. Okay. The next one, B. 17 equals 2 times e to the x. Once again, the unknown is in the exponent position, so we need to change it to a logarithm. But first, let's divide by that 2. 17 divided by 2 is 8.5. So that'll be 8.5 equals e to the x. And we can change this one to the natural log. It'll be the natural log of 8.5 equals x, which is definitely a exact answer. So we don't need to change a base since it's base e. So let's see, natural log of 8.5 is 2.1401 if we go to 4 decimal places. And the last one here, 620 equals 3 raised to the x minus 4. So we need to get that x minus 4 out of the exponent position, so we'll change it to logarithm. X minus 4 equals log base 3 of 620. We'll use a change of base. X minus 4 equals log of 620 over log of 3. We can move that 4 over if we want a exact answer with x by itself. So it'll be plus 4. But if we're going to get a decimal approximation, let's go to the calculator. So log of 620 divided by log of 3. And then plus the 4 that I moved over is 9.8526. And you can put that in for x in the original problem and see if it works out. Okay. Let's see, we got a couple more problems down here. It says solve the following. Did I skip some? I believe I missed a couple here. Yes, I missed a whole row. Solve the following. Okay, so we got some that start off in log form instead of exponential. So 6 equals natural log of x. So to get that x out, we're going to change it to exponential form. So we're going to go the other way. So we'll have e to the 6 equals x, which is definitely an exact answer, but putting that into the calculator, x is about 403.4288. 403 and a little bit more. The next one, x equals log base 2 of 37. Well, that is an exact form and it's already solved because the x is by itself. But let's use the change of base to get ourselves a decimal approximation from the calculator. So that'll be log 37 over log 2. Log 37 divided by log 2. So I'm getting 5.2095. And if you have any trouble getting the things out of the calculator, let me know. The last one for these, 5 equals log of x. There's no base listed, so it's understood to be base 10. So it'll be 10 to the 5th equals x when we take it to the exponential form. That is an exact answer. It will come out nice. It looks like it's exactly 100,000. So very nice. Alright, just a couple more problems down here. Don't go too far. So we're going to solve these. It's 57 equals x cubed. This is a little bit different because if you rewrite it in exponential form, you get log base x of 57 equals 3, and that's not really helpful because you don't have the x where you can work with it. And the x isn't where you can work with it in the exponential form either. But what you can do is you can take a fifth root of both sides. So we'll say 57 equals x cubed, a cube root. So we're going to take the cube root of both sides to get rid of that cube on the x. So x equals the cube root of 57. So we'll do that in our calculator. And let's see what we get. We get the x is approximately 3.8485. Okay. The next one, log base x of 400 equals 5. So the x is definitely not where we can work with it. So we're going to move it around, change it to x to the 5th equals 400, and then it's like the problem we just did a second ago. We're going to take the fifth root of both sides. So that gets the x by itself. So x is exactly the fifth root of 400. But Mr. Calculator is going to tell us that that would be, let's see here, about 3.3145. And anytime you solve an equation and get an answer, you can plug that answer back in and see if you are correct. All right.